Good morning, everyone. Happy World Cup to all who celebrate. I think that starts in an hour for the US. Welcome to a first time HVAC systems testing for energy efficiency with Lester, Lester, I think you did a motors training for us in the summer. It was really great with DNR Learn. It is also snowing in Seattle. Oh no, it looks like maybe it stopped, but bundle up and prepare, everybody. Let's see, next slide there we go. If you haven't taken a class with us before, you're muted the whole time, but you are more than welcome to ask questions at any time in the chat, and Danny and Lester will get those answered. This is being recorded. Right when I started talking, lucky us, we get all this recorded. And after class, there's going to be a little survey that we would love you to take to let us know how we're doing, maybe suggestions on other topics you'd like us to cover. And then this is a two-part class. So if you are not signed up for day 2 this Thursday, go to thelightingdesignlab.com and get signed up so you don't miss it. And we have one more class this year. It's actually not a class, it's a case study on the Bayview Tower Apartments here in Belltown. They did a retrofit and put in CO2 heat pump water heaters instead of the electric water heaters, and it's been a great success. So come hear about that 100-unit multifamily building next Tuesday. All right. I think I said that I'm Katie. If you have any questions, write us at lightingdesignlab.com or lightingdesignlab@seattle.gov rather. And other than that, ask questions all day in the chat. And I will hand it over to Danny and Lester. Thank you, guys.
Thanks, Katie. Welcome, everyone. My name is Danny. I'll be your moderator today. I'm here with your instructor, Lester Terrance, for HVAC systems testing for energy efficiency. We're going to be together for 2 hours today, and our goal is to take a break in the middle so we can fill up some coffee mugs, we stretch, or use facilities. But today we're going to be using the chat feature for any questions that come up. There's going to be some scheduled pauses in the webinar, and at this point in time, we can address those questions. And then based on how we're doing with time, we're hoping to provide an answer to all of your questions in the chat. We're also going to be using the Slido feature today. This can be accessed through a smart device, and I highly encourage everyone to take advantage of those polls, surveys, and questions. I'm going to be in the background providing some links and resources, so you can look out for those in the chat. But without further ado, I'll hand it over to Lester so we can kick off HVAC systems testing for energy efficiency.
All right, Danny, thank you. Just want to do a quick check for my mic. Is everything good to go, Danny?
Yep, your mic's working.
All right, awesome. Can we see the screen for HVAC systems testing for energy efficiency?
Yes, we can.
Awesome sauce. All right. Hello, everyone. I hope everyone's doing great today. We have a great course for you, HVAC systems testing for energy efficiency. I will be your instructor today for roughly 2 hours. My name is Lester Terrance. Let's go over a quick introduction of my background before we get started and jump into things. Once again, my name is Lester Terrance. I am an HVAC instructional designer and also an instructor for DNR International. My background is in HVAC. I started my career with the United States Air Force a little under 20 years ago, where I worked as a 3E1 X-Ray 1, which is an HVAC apprentice, and worked my way up to an HVAC journeyman. Spent 12 years in the Air Force, traveling around the world, working on HVAC applications. And I got out after 12 years and had an opportunity with the Department of State as a contractor, where I worked for 7 years as a field supervisor, monitoring field teams, providing preventative maintenance and repairs to embassies and consulates for the State Department. So I did that for about 7 years, had a great time, traveled to a lot of different countries around the world, working on different HVAC systems and applications. And now I'm here with DNR. I've been here for about a year, writing and also providing instruction on HVAC applications and any type of emerging technology within the trade. All right, let's get into why we're here today. Some of our objectives are listed on screen right now, and first and foremost, I believe we noted that this is going to be a 2-day course. So today is going to be part 1, and on Thursday we're going to have part 2, the second portion to our HVAC efficiency testing course today. But today we're going to go over a few learning objectives. And first, we're going to go ahead and cover the introduction to HVAC systems testing for energy efficiency. And this is where we're going to define the purpose for mechanical and electrical plants. We're going to discuss the different applications relevant to a plant's operation. How does that plant operate on a day-to-day basis? Excuse me. And also identify the different equipment that's going to be responsible for that application's performance. The second objective that we have will be to understand testing and data acquisition tools. This is where we're going to recognize the different data acquisition system components. And then from there, we'll be able to identify the different HVAC measuring and or testing instruments that are available to us today in the field. And then lastly, our third objective in our course will be to examine the different types of systems or the different ways that we can evaluate and test our HVAC systems. We'll have an HVAC jigsaw system testing jigsaw to go through, and we'll also talk about system maintenance and upkeep. So today we'll have Danny in the back providing our moderation for the course today. And he did speak about our Slido.com app that we will be using for activity sessions that will present itself throughout the course today. We will have question and answer sessions for maybe case studies that may pop up or just checking for understanding. And we utilize Slido.com in order to get you to participate in these different activities. So when the opportunity does present itself, you will head on over to Slido.com, where you will see a QR code at the top left-hand corner of the screen when an activity presents itself that you can scan and have that take you to the site where we will answer any questions or any requests that are made through the Slido poll. Once again, that's Slido.com. And if you're not going to use the QR code, you will enter the event code EEHVAC. Now, both the QR code and the event code will be present on screen for you to access that activity session. And also, Danny will be placing the link in the chat area for you to access as well. Slido is a free application. Please do not worry about it tracking any of your information. It's just a third-party application that we utilize to provide you with your activity portion of our presentation today. So what we're going to do right now is go into Slido.com and do two things. One, we're going to test our access to Slido by making an attempt at this introduction survey that we have present. And what the introduction survey is going to serve as is part 2, which is where we get to understand and learn a little bit more about each other. So one, we're going to go ahead and test Slido.com, the application and polling application, so that way we can make sure that everyone is able to access Slido.com and take part within this polling application. And then from there, we're going to review all of those different answers that we are receiving. Give me 1 second here. Let me get my, let's grab this one. I will do. All right, that shouldn't be a problem anymore. Okay, so we'll take about 2 to 3 minutes here. Looks like we have a few people able to get into the polling app, which is good. We'll take about 2 to 3 minutes here, have everyone go ahead and go through the introductory survey and just introduce yourself, which after we have a decent amount of individuals taking part, we'll go ahead and review those answers and then move forward with our presentation. So take about another 2 to 3 minutes here, go through the Slido poll, and we will review those answers and move forward with our presentation.
And I just want to chime in here that I have the Slido link in the chat there and the code as well. So if you're still looking for that, everything is in the chat.
Danny, during these type of pauses in between where we're waiting, it would be nice to like have elevator music just to kill that silence a little bit. I think
It
I've
really
thought that.
would.
Yeah.
I'm gonna have to look into that.
Yeah, I think I'm gonna bring it up and see if we could get something going. Because we do have some times where we go a little longer, given the audience time to answer some of these different polling sessions. So we'll see. We'll see how we can make it happen. Oh my goodness, this is back. I thought I closed it out. Just give me 1 second here, because this is going to be a problem. Excuse me for 1 minute. To do it hopefully this time. All right. All right, so let's jump into it. Looks like we've got a good bit of our class, I think over half, so far that has answered the poll. So let's go through the polling for the introductory survey. So first question is, are you a tradesman? No tradesmen here, no HVAC electricians or plumbers present today. Rate your level of comfort in understanding of HVAC. And we've got 62% of our attendees pretty good understanding, and roughly 38% just getting started. This course right here is going to be a decent course, a good course for your beginner learners of HVAC, just because it shows you a lot of different basics for HVAC, and also you get to dive a bit deeper into the instruments that are used in order to test and keep HVAC applications running optimally. Rate your understanding of HVAC systems. I've heard of them at 77%. So you know what they do, you know where they're pretty much located. So that's a good start. And we've got 23% at I work on HVAC systems. So we have some gurus in here, or some individuals with experience that understand the process of HVAC applications. So that's also a good thing. Please, for those individuals that do have experience on these systems, please feel free to chime in and provide your experiences as well on anything that we may have answered, or you have any input to provide. All right, so I'm gonna toss my camera on really quickly just to let everyone know throughout the presentation today, I'm going to pretty much leave my camera off going through, but I'll be popping in and out through the presentation just to save on bandwidth. Today it's been a little tight, not sure why, but we want to try to keep this presentation running as smoothly as possible. So let's jump right into our presentation today on HVAC systems testing for energy efficiency. And we will start with talking about what parts of an HVAC system requires evaluation. And by doing so, we are going to look at the applications of mechanical and electrical plants, which are very important. You want to understand what are the different applications that are present within your electrical and your mechanical plants. Now, your mechanical and electrical plants contain all the equipment, including piping and wiring, which is required to provide the essential services to sustain any type of occupied building and or facility. Now, those facilities may contain personnel, IT office equipment, which requires cooling or some combination of both. These facilities are often noisy, and hearing protection is recommended and required in louder facilities. So any of these facilities where you have the mechanical rooms, it's going to be important to wear hearing protection when entering those areas, because over time you can damage your hearing. Now, the services provided directly from mechanical and electrical plants are some of the following. You have the ability to get running water, utilities, sewer, waste, heating applications, your domestic water use, comfort heating, steam use, any type of cooling applications, your comfort cooling, your equipment cooling, and also on the electrical side, you have your electrical hub for power distribution. And also, if you need or you have that redundancy, you have backup generators for any type of power loss that you may observe over time. Now, these are just some of the several important services that are rendered from the operation of mechanical and electrical plants, but we'll dive into some of these a little bit more as we go on through our presentation today. So what parts of the HVAC system needs to be tested for efficiency? So what we've done here is we've kind of broken down your mechanical and your electrical plants in order to show exactly where you're looking to test for efficiency in both of those areas. Excuse me for 1 second. There we go. So in our mechanical plant, if we look at our diagram here, and let me see if I can get my trusty laser pointer out. So if we look at our mechanical plant, we have both our mechanical plant and our electrical plant down here. But if we look at our mechanical plant, what we've got going on is we've got heating and cooling as far as services happening at our mechanical plant. And heating is supplied to zones within a facility for any type of comfort heating when the ambient temperatures are extremely low outside. You also have domestic hot water, which is also a byproduct of any type of heating application. On your cooling side, you have your chillers, and your chillers supply chilled water to different zones within a facility for comfort cooling or any type of moisture control. Now, you have different types of systems that are used in your cooling applications, such as package units, which could be supplemental systems, are also used to provide any type of comfort cooling. DX systems are also another example, which are used to provide supplemental cooling to a cooling system where chillers are the main application. Now, you also have domestic water treatment and distribution that happens at your mechanical plants, and water is chemically treated and the pressure is regulated before any distribution to the facility. So whether that is at a commercial office facility or a residential facility where you have maybe an apartment complex, the water treatment is extremely important because you have to regulate the pressure and the quality of that water at those different facilities. So all of those different items will be maintained within your mechanical plant. Now, over on our electrical side of the house, we have a few different things that is happening within our electrical plant. And power solar generation is one of them. So the use of generators to supplement any type of secondary or redundant power from any type of power loss that may have occurred from your commercial or primary power source. And also you'll have all of the setup for your solar applications located at your electrical plant. Now, electrical distribution systems are also a part of your electrical side of the house, where your transfer switches, motor control centers, your transformers, and also your UPS, or some of us may know them as UPS systems, are located as well. And lastly, your BAS, or building automation system, which is a system that is used for measurement and verification, and also the control of building lighting and mechanical and electrical services. So we'll touch on a few of these different items as we go through our presentation today, so you can become a little bit more familiar of what applications and their components are running in a mechanical plant, and the same for the electrical side of the house. Now we're going to identify electrical systems and some of their components as we move through the electrical plants when dealing with energy efficiency for those types of systems. And we're going to pay attention today to, when talking directly to power distribution systems, we're going to pay some attention to our switchgear, transformers. We're going to talk a little bit about generators, the MCC, or also known as motor control center, and we'll dive into solar power as well. Now, as we can see here, one part of our power distribution system is we have a component which we call switchgear. And switchgear is a system which has a combination of circuits or fuses, which is used to isolate or protect and control electrical equipment or any of the gears from any type of defective condition. Okay, so one of the uses for this switchgear is to transfer power within your site. And a lot of the time you will find that electricians are who are mainly working on this type of a system. You will not find an HVAC technician or anyone other than a qualified electrician working on switchgear. Now, switchgears, like I said, is part of the power distribution system, and part of that system, you will have equipment such as chillers, RTU units, air handlers. All of these different systems receive electricity through the use of switchgears within the electrical circuit of the system. Now, on our slide here, you can see we have an image of an exterior and an image of the interior of our switchgear system. And on the exterior of our system, a lot of the time you can find information if there is an LCD screen present that will show you what the different voltages or amperages or any type of electrical information that's required, you can find present on an LCD screen dependent upon the manufacturer or vendor which creates these different systems. And then on the inside, you're going to find any types of fuses that will be part of the system to allow it to operate the way that it needs to. So your exterior, you're going to find any type of start, stop, hand off, on, auto switches, any type of LCD screens for quick access and reading of your electrical signals. And on the interior is where you will find the hardware of your electrical system for that piece of switchgear, whether that is fuses or other electrical equipment or components. Next, we have the MCC, part of the power distribution system or your motor control center. And the MCC is an assembly that is placed inside of mechanical rooms to control some or maybe all of the electrical motors in a certain isolated or central location. It consists of multiple enclosed sections which has different, or not different, but has a common power bus with each of the sections containing a combination starter. So you'll have your motor starter, your fuses, your circuit breaker, and your power disconnect associated with the MCC power distribution system. Now, these MCC systems, you will find a lot of your motor systems that is used with HVAC applications connected to directly to these MCC panels. And if you look at this image to the left very clearly, a lot of the time, what you'll find is each one of these sections of the MCC will be allocated to maybe one motor. Okay, so you'll have your ability to, once again, depending upon your manufacturer or your vendor, you have different options that are available to you, such as an LCD screen that might be showing you the energy characteristics of that motor system as it's running in operation. You also have these lights that will show you different things that are happening with the motor at that current time. So if it's running, it's typically in a green light mode. If it's off, it's typically in a red light mode. And if you have any type of alarms, you might have like a yellow or maybe even an orange light that lets you know, hey, the motor is an alarm. You need to check in on it, figure out what's going on. So these panels or systems are very important in tracking what's going on with your motor, at the very least at the manual level, meaning that you have a technician on foot providing inspections on a daily, and they were able to catch that, you know, you have an issue with your motor system because they were doing an inspection on the entire MCC. So these MCCs are pretty cool because all of your motor connections are directly here, and you'll be able to isolate your motor system here and do any type of work you may need to do on it. So one more thing about the MCCs is that they're typically found in large commercial and or industrial buildings where there are many electrical motors that need to be controlled from a central location. Once again, that's such as any type of mechanical room or electrical room, plant or room, same thing. The mechanical room might be a little smaller, will be a little smaller than your mechanical plant. Over to the right here on the interior of your MCC panel will be the components, the electrical components that's used to either power your motor system, such as fuses or even any type of magnetic line starters you'll have associated with your MCC or motor control center. So that way you have the ability to provide electrical power to your motor systems. Just want to throw one more thing in there that VFDs are other types of systems that can be associated with your MCC for power or control of the actual motor system. So you can do a combination of different systems when dealing with your MCC panel. Next up, we have transformers when talking about power distribution systems. And on screen here, we have several different transformers, but let's talk about what a transformer is before we get into these. Now, a transformer is used in power transmission to transfer any type of electrical energy from one electrical circuit to another, or within multiple circuits at the same time. So to make things simpler, it's just a voltage control device that's used to distribute and change the transmission of power. So you can have different types of transformers for several different reasons, but the more common types that you'll find in the field are step up and step down transformers. Now, I think we have one on screen here, step up, step down transformers. Now, when talking about step up and step down transformers, Your step-down transformer converts your high voltage energy from the primary side of your circuit to low voltage on the secondary coil, resulting in a decrease of the output voltages. So an example of this would be if you needed 24-volt control circuit voltage in your system, you can place a step-down transformer inside your control circuit, inside of your circuit, so that way when you distribute that 24-volt circuit uh, uh, voltage that you require on that control side, it'll be stepped down from whatever the primary voltage is. Let's say it's 120. So you can go from 120 volts on the primary side to 24 volts control voltage on the secondary side by utilizing a transformer system. Now, single phase, three phase, types of transformers. When you talk about single phase, the single phase transformer is a type of power transformer that uses single phase alternating current. And then your three phase transformers are transformers that utilize your three phase current. And these are more of the more common types of transformers that you will find out in the field today. And you also have a few others, such as some of these listed on screen. Your iron core transformers are pretty common in the field today. And what you'll see is what we've spoken about, these three-phase step down and single phase power transformers are the more common types. Now we can kind of tie everything in when we go through the power distribution system to see how all of these different components come together. So in the beginning, we spoke of our switchgear, which is going to be this device right here, which is going to receive the commercial power coming in from the utility. And what's going to happen is that commercial power is going to be sent over where it's required. But before it gets there, the transformers that we spoke about is going to reduce that power coming in from the utility, because the power coming in from our utility is normally pretty high. You're normally at a large facility, you're probably going to have somewhere around 600 volts coming into that facility. And what's happening is your feeder or your switchgear is going to have that power transferred over to where it's needed, but your transformer is going to reduce that power load. So that way it is exactly what we need where we need it. So if we needed to power these motors over here down at the bottom, what's going to happen is we're going to have our power come through, and it's going to be stepped down to whatever the voltage is for these motor systems. So if this is a three-phase 240 system here, we will have the power reduced from 600 to 240, and then we'll be able to power these motor systems down here. Now, you also have your switchgear, not your switchgear, but your MCC, your motor control center. Let's remember this here. Your motor control center is what's going to be used to isolate power or send power to your motor systems. Okay, so this is where you're going to be able to see the lights. Either it'll be green, red, or yellow. If you have an issue with that motor is not running, it'll send a signal back that will turn the light red for off, but then you'll also have your yellow light on for, hey, we've got a trouble, an alarm, something's wrong, we can't move any water with this motor system. And over to the right here, you have pretty much the same process, but on the lower end of things, where you have your single phase circuits, such as your light switches and other home type of electrical needs. So you have a transformer that will bring this voltage down to what you need for your residential applications. Okay, so these are the different systems that are involved when talking about power distribution within your HVAC systems. Now, we also have generator and UPS operations that happen within our electrical side. And a lot of the time you'll find these systems in place for redundancy. Your generator systems is typically any machine that will take mechanical energy and convert that mechanical energy into electricity for transmission and distribution. So if you needed to have a secondary source of power for your facility, you can have a generator on standby that will allow you to power your facility in the case of commercial power loss. Over here to the right, you can see we have UPS battery or UPS system battery backup. And what UPS stands for is uninterruptible power supply, or UPS system. And it's just a system that provides emergency power to a load when the input power source or mains power source fails. Now, this image that you're looking at here, I worked with some power generation teams when I served in the Air Force, and we worked out of one of these rooms for a mission that we supported. And it was impressive to see how much redundancy was in place for some of these systems, because they couldn't have these missions go down or fail. So this backup battery would be almost a backup to the generator system as well. So you can have your generator system, which they had well in place. They had a generator system in place, Caterpillar 1.5 meg gens, 2 of them, with a battery backup for the specific facility that we were working out of. So depending on what your mission is, what your customer base is, you'll find a lot of major retailers. I know I did some work for Amazon for a little bit. They have these same types of systems in place, so that way, when they do have the loss of commercial power, they're able to come back online, or you have minimal notice that you were even switched to redundant power. So once again, you have your generator, which can provide electricity to your facilities and all the components that requires it. And then you also have UPS, battery backups as well, which is another form of redundancy for your facilities. And then lastly, within our electrical side of the house, we have our PV technologies, or also more commonly known as our solar panels, which generate power using devices that absorb energy from the sunlight and converts it into electrical energy through a type of semiconducting material. Now, these devices, which are known as solar cells, then are connected from larger power generating units known as modules or panels. And this is just an alternate source of stored power. Now, the benefits of solar generated power is that from use, we've come to understand that it does help to reduce air pollution. We do know that from the use of fossil fuels, we can create a lot of pollutants in the air. Utilizing the solar panels does reduce dependence on any type of non-renewable energy source, and it improves humanity's health in the long run. It also helps to fight any type of climate change, and we can utilize our solar panel systems to assist us with any type of load shedding through demand response events. So having these solar panels in place and taking advantage of any of the programs that are available for these solar panel systems would greatly benefit the consumer, and also it would help out our climate in the near future. So something to think about when looking to make any type of energy upgrades or electrical upgrades to your facility or even to your home. So we just covered the electrical side of the house, where we spoke about some of the electrical components and systems that are available when talking about HVAC energy efficiency. Now we're going to identify some of the mechanical systems and components that are available when talking about HVAC components and systems. So we've got when talking about mechanical systems and components, we've got heating as far as an application, cooling, and then the pumps and also the air handler unit systems that will be moving the air that we require in the different zones for HVAC. So let's jump into the world of the heating application. So here, we're going to talk about the different types of heating apps. And we do have boiler listed, VRF systems, which means your variable refrigerant flow systems, and also your heat pump water heaters. Now, your boilers, we know that boiler systems are utilized with natural gas as the resource for combustion. Um, with our boiler systems, we know that they are much faster in heating our loads and does have the potential to carry a larger capacity and a lot faster than our other systems. Next up, we have our VRF systems, variable refrigerant flow. And with these VRF systems, or variable refrigerant flow systems, they are great systems or applications because they provide flexibility. And we'll get into why that is in a little bit. And we also have our heat pump water heating systems, which are extremely energy efficient. And your heat pump water heater systems can provide us with domestic hot water heat recovery. Oh, and I just wanted to mention here with the heat pump systems as well, you can have a heat pump system provide comfort heating to your residents as well if you have that option present or you would like that option within your cooling application. So your applications that uh, the heating types would be suitable for is heating on a super cold day or provides comfort heating when your ambient temperatures drop below, let's say 33 or 32 degrees Fahrenheit. So we are able to stay comfortable inside of our homes or working spaces because we have the ability to turn these systems online. We also have the ability to create domestic hot water for showers and also personal use. And lastly, let's not forget our industry. For commercial kitchens and such, we utilize any type of hot water made or steam for sanitary uses, such as cleaning kitchens, kitchen floors, degreasing, and those types of items. So here we have an image of our heating boiler or gas-fired boiler and also a heat pump water heater. Now, as we discussed earlier, we know that boilers heat water and they provide either hot water or steam for heating. Now, this steam is distributed through a system of piping to radiators that are located throughout the different zones or spaces that requires that heat load. And you can even have that hot water distributed to baseboard radiators or even radiant floor systems that can also provide the same type of heat. Now, the image that you're seeing here on screen is a natural gas boiler. I know our attendees, most of you are out in the California region. I promise we won't talk about heat too much because I know it's not a lot of it out there, but we just still want to cover these systems. It's important to know that they still exist, they still are out there, and what are the ways of testing these systems. But here we have our natural gas boiler. And this boiler uses gas or any type of bulk LPG that's stored directly on site in some sort of a storage tank. The gas that's brought into this system is burned in the boiler's combustion chamber located up here and warms any type of water that's inside of it to around 158 degrees and higher. Okay, you have oil-fired boilers that pretty much looks the same way, and also electrical boilers. You won't see them in this. I haven't personally seen them in this round configuration, but you do also have electric boilers as well. Your oil-fired boilers, instead of using gas, it's using oil, to heat your home or business. The oil-fired boilers work much like a gas boiler. It just has a different source of fuel for combustion. Your electric boiler does the same thing, same process. It heats your home or your business. It's just a device that uses electrical energy to boil that water or heat that water than the use of oil or gas for combustion. Now over to the right, we have our heat pump water heaters, and our heat pump water heaters use electricity to move heat from one place to another rather than generating its own heat like a traditional electric heater, water heater. Now, using these types of systems make them 2 to 3 times more efficient than your traditional systems. Now, if you look at these heat pump systems, if you understand the refrigeration cycle or the vapor compression cycle, think of a heat pump water heater as a refrigerator working in reverse, or a air conditioning system working in reverse by way of a three-way valve. So for my individuals in class today that has HVAC experience, your heat pump water heaters are just air conditioning systems working backwards, if you want to look at it that way. And these systems are extremely energy efficient to utilize. And what's happening is this system right here is taking the heat energy out of the air or ambient temperatures outside and transferring that inside to this system where it's able to create hot water. Let's take a look at the world of cooling applications. We just covered heating applications. Let's take a look at the world of cooling applications. So we have cooling apps and the different types of cooling apps. We have chillers, VRF systems, and also mini splits. Now, your chiller systems are systems that are utilizing water, or the source or medium is going to be water to provide that cooling to the different zones that's required in an extremely large facility. And those facilities are typically housing mechanical rooms that have air handler systems, which houses cooling coils. So this chiller is going to create chilled water that's going to be sent out to your cooling coils in your air handler system, which is provided downstream to your offices, spaces, or zones. And we'll touch on our chillers here a little bit more shortly. Then we have our VRF systems, which once again are variable refrigerant flow systems, really flexible systems. These systems are some of the newer type of applications available for businesses that give you a lot of different options. And we'll touch on some more of those options here in a sec. And then you have your mini splits, which are your split systems containing an indoor and outdoor system that is able to provide us with cooling when we require that. Now, we know that we need cooling for comfort. On hot days outside, we definitely need to get cool. It also helps with our health to stay a certain temperature. So cooling helps in that aspect there. Technology. I've worked in the technology department as far as being an HVAC tech in my earlier days, where AC was I'll say it was very, very important in the technology world. So the time that I spent with Amazon, I maintained the cooling for a lot of their data farms. And when we lost cooling, it was a problem because your Netflix went out. So for that short 5 minutes that you lost connection with Netflix, it typically wasn't your internet connection. It probably was a server, something that happened to go down, but it was able to be brought back up extremely quickly from the work of several professionals on site that worked together in order to have those systems come back online. And HVAC is one of them. So when you have these servers working overtime and they are generating an extreme amount of heat, they can burn out if you don't have the proper or adequate amount of cooling. And also, cooling is utilized when talking about produce and the delivery of produce, storage of meats and produce. You have now delivery trucks that contains air conditioning capabilities, which allow us to transport those goods from one end over to the other and still maintain that freshness of the produce or those meat products until it reaches its final destination.
Hey, Lester, it looks like we have a question in the chat before you move on from that slide.
Absolutely.
We have a question here that says, as we head towards zero carbon, what will replace gas boilers? Do you know of HPWHs that are readily available for HVAC use?
So heat pump water heaters. Okay, so that's a really, really good question. There is, and I'll try to tackle that because what I want to do is I want to give us a break here in about 10 minutes because we have been going a little while. I want your minds to try to absorb some of this before we move forward. But there are several different options that are becoming more widely available today that has the potential to remove natural gas-fired boilers from specific systems, such as heat recovery options. When utilizing either compressed air systems, excuse me, compressed air systems, or even capturing rejected heat loads from several different sources, whether that's power generation or even the creation of cooling or chilled water for cooling. The heat rejection that you receive from that can be reclaimed or recovered and used in order to create heating or heat loads. And it's been around for some time, but the technology has gotten extremely advanced today. What I will do is, for the individual who asked that question, I do have some links for heat recovery options and also heat pump water heating or heat pump systems in general for having alternate options when looking to go from natural gas fired systems or oil fired systems over to more uh, how do you say this, more energy efficient systems that are available. So yes, there are options that are out there, and electric is one of them, that you can use electrical boilers that are out there today. But I will give some options by way of uh, website resource when we get a chance here shortly. Was that the only question, Danny?
Yeah, Lester, so it looks like we also have another comment here saying, I think the question was about replacing gas-fired chillers, not replacing gas-fired boilers.
Gas-fired chillers. Is someone asking a question about gas-fired chillers?
It looks like the first question was about the gas boilers.
Yeah,
So
I think that was more online. The gas-fired chillers. Okay. So what I will do is I will leave the resource. I will get the resource and put it in there on heat recovery options for natural gas-fired boilers. So we'll go through this, and then once we get through this mechanical section, we will take a short break and dive into the second half of today's course. So on screen here, we're still talking about cooling applications and cooling systems when talking to mechanical plants. And here we have chillers and split systems. So our chillers, you can have several, well, not several. Let me make this very, very clear. You can have two types of chiller systems. You can have your air-cooled chillers, which are these down here, and you can have your water-cooled chillers, which are going to be these here. And these systems, let's talk about air-cooled first. Your air-cooled chiller system is typically limited to about 500 tons of cooling. And you'll find these systems staged outside in a chiller yard. You're going to want to have them locked up, not too easily accessible. the system in itself supplies chilled water to a cooling coil within an air handler. And I'll go through that process when we get to our air handler system. So just remember what the system looks like that is creating the chilled water coming to your air handler system. Now once again, your chiller is going to supply chilled water to your cooling coil in your air handler system. But the chiller in itself is really good at supplying cooling for IT server spaces. And a great example of that is for chiller rack systems, where you have chilled water directly pumped into cooling coils within the rack systems where servers are located. Very, very complex and expensive system to integrate into your IT operation, but it will drastically reduce the amount of BTUs emitted. Well, it won't reduce it, but it will be able to handle it by rejecting that heat load out to the ambient air. It'll have enough capacity to do so, because you're literally pumping chilled water constantly through the coils that are in that server rack within its heat exchanger. So it's a really, really sweet system, and these chillers are great at doing that as far as air-cooled chillers are concerned. Now, your water-cooled chillers, same thing, same operation, not type of operation, but same type of cooling delivery you'll get from both systems. But your water-cooled chillers are a lot larger than your air-cooled chillers. These systems have the capacity in the thousands of tons. So when you have applications such as campuses that require cooling, you're gonna probably enlist the help of a water-cooled chiller in order to do that, and you will have this located within a mechanical plant. So this system will be located in a mechanical plant, and the biggest difference between your water-cooled chiller and your air-cooled chiller is the water-cooled chiller is going to come with a component known as a water tower or a cooling tower. Okay, but other than that, both these systems are going to be supplying chilled water at roughly 44, 43 degrees Fahrenheit on average, if we're talking about a facility or a campus. You're going to be producing 44 to 43 water chilled water, 44 to 43 degree chilled water to your air handler coils or your fan coil units if you have those installed throughout your different facilities. You also have RTU systems. They're not shown here, but the capacity is up to a little over 100 tons. These types of systems usually exist in smaller facility applications, and all of your components for this system is located in one unit. That's why they're sometimes called or referred to as packaged units. So your rooftop unit or RTU system, it has a capacity of up to about 100 tons, and they're for smaller facilities. But the main thing to remember is that all the components for this system are located in one unit. And when I speak of the components, we're referring to the compressor, the metering device, the condenser coil, and also the evaporator coil, which we'll see here shortly when we get into the air handler unit portion of things. And you also have DX or split systems. Your DX systems are going to be a combination of an inside unit and also an outdoor unit and also an indoor unit. Your indoor unit is going to provide your space with the cool air required or needed, and your outdoor system is what is going to be doing the heat rejection or removing that hot air buildup inside and rejecting it outside to our condensing system. And then lastly, we have our VRF system, which uses heat pumps or heat recovery systems to provide both heating and cooling for all your indoor and outdoor units without the use of any type of air duct system. So what's really cool about these VRF systems is that you can have I won't say end, but I'll say you can have the system that is indoors, your indoor system, you can have different types of indoor systems connected to your VRF system. So you can have a ceiling cassette type, or you may even have these wall hanging types when dealing with the VRF system. But once again, the best thing about the VRF system is it utilizes one outdoor system for multiple indoor units, and you can have the control of both heating and cooling with the VRF, or variable refrigerant flow system, shown here. So with a VRF system, your building will have multiple indoor units, which is utilized by a single outdoor condensing system, either with heat pump or heat recovery. Next, we have our pumps, and our pumping system is pretty much what we have here on screen. A system that is going to move liquids or any type of gas where it's needed. Pumping systems can be found in most of your hydronic applications for facilities, and they assist in some of the following applications or operations, such as supply and return of boiler water systems, supply and return of chiller water systems, your domestic heating water supply, your sump pumping stations, and also supply for gas or any type of oil if it's being utilized. So once again, pumps are just mechanical systems used for moving liquid or any type of gases to the applications or components required. Pump that you're seeing here on screen is a much larger pump. This pump is probably utilized for a chilled water application as a return or a supply pump in a facility system. Now here we have, lastly, the last component of the mechanical side of the house that we're going to talk about. Very important system here. What we have here is the AHU, or air handler system. For some of us that are HVAC technicians in class today, you may have heard this system called the AHU unit, but it is an AHU, or air handler unit system. And the air handler unit system is usually set inside a facility where you can have both your heating and cooling components of your HVAC system put together in one. So what your air handler system is utilized for is to draw in air and also supply air and exhaust air from your spaces within your facility. So you will have a supply blower, which I'll show you that here. Here's your supply blower. So that is connected to a motor system down here. Let's go back, apologies. You have a motor system down here that is able to turn a squirrel cage in here that is able to blow out the air to the different spaces that it is needed. And then you also have a return blower. And what's important about this return blower, which has a motor here, is that it is removing the used air. So all the air, that CO2 that's now left in the space, is being removed by our return air system on our air handler unit. And that's being exhausted to the ambient air, where it's okay, it'll be out there and go for whatever uses it has, but we will always continuously draw in fresh air. I like to cover this part and say, I know here on the East Coast, we're regulated to 10% outside minimum air coming in here in Maryland, where I'm at. And I believe it's about the same for California. So in any major facility that houses air handler unit systems, your dampener system, which should be BAS controlled, makes it easier for you to have that type of setting in place, where you always have at the very least 10% minimum outside fresh air coming into your spaces. So veered off a little bit here, but the part I want to talk about on the air handler unit system is the coils. So remember, we spoke about the chiller system and the boiler system supplying hot water or chilled water to a coil that is going to then have air drawn across it in order to provide that heating or cooling to the space. So you can see here designated by some colors, we have red for heating and we have blue for cooling. So when you are in heating mode, there is no cooling. That is offline. So what you're having happen here is you're having hot water transferred from your boiler system to this coil. And what's going to happen is when this fan comes online, it's going to draw that hot air. It's going to draw the air across the coil, making that air now a certain temperature as it's sent out to the different spaces where it's required. The same operation will happen when you have your cooling. You will have the chiller system, which we spoke about earlier, send over that cooling chilled water to the coil, the chilled water coil, and then when this fan comes online, it's going to draw air across that 44-degree coil. So typically you'll have about maybe a estimate at about 175, maybe even 175-degree water sitting in this heat exchanger or coil here. So your air temperature, by the time it starts blowing downstream, it'll probably be somewhere around, I don't know, 120, and then it'll start dropping gradually from there. So 140, 130, 120. By the time it hits your diffuser, you're probably going to be sitting at about 90-degree air if it's in heating mode. Now, on your cooling side of the house, you're going to have about 44-degree water sitting inside of this heat exchanger or cooling coil. And once it's drawn across, you're probably going to have about maybe 40-degree air leaving the air handler. But by the time it gets to the zones required, it's going to probably pick up about 10 degrees delta T at that point, and it will it will still be able to cool that space down, but it won't be as cool as it was because it has a ways to go to reach different zones. So for your air handler systems, just want you to remember, this is where your final destination is for your cooling and heating loads, which needs to be delivered. Your cooling here, your heating here is going to happen at the heat exchanger, and the cooling at the heat exchanger. Two separate coils. It's not going to happen within the same coil. And from there, you will have your heating and cooling happen, and any type of return air brought back out to the or drawn back out by a motor system to the ambient space. And then you have that operation continuously happen within your system as long as there is calling for that to happen. All right, what have we got here next? We do have a case study that is coming up next, but what I want to do is I want to leave this on screen. And for those of you that get back a little early from your break, what I'd like for you to do is follow the link to this specific case study and take a look at the article, read the article on studying how plants are actually designed. And then we have some Slido questions in the Slido poll to follow. So what we're going to do right now is we're going to go ahead and we're going to take a break. We'll take about 10 minutes and get some coffee, water, get a good stretch, bio breaks, anything you need to do, because we will press forward with the rest of this course here as you get back or you return from break. But for those of you that get back early from break, you can get started with this case study here by reading it. And what we're going to do, Danny, if we can add the case study link to the chat, so that way our participants have the link, they can follow to the case study. And what I will do is I will move forward to the Slido application. Let that be present for those of you that want to start working on answering that poll. So let's go ahead and take 10, and I will see you back here roughly 20 after the hour.
Sounds good, Lester. Thanks.
Right. So we're still on break. Please take your time. We'll give everyone. Looks like a few people have engaged in the Slido activity so far, but we will give everyone some time. You still have enough time. Please take a look at that case study there, and then join us on the Slido.com app, and we will come back and look at what our answers are for those polls. So see everyone here back shortly. Looks like we still got some attendees still working on the Slido poll, which is okay. Please take your time. We want to get as many individuals in there as possible. Your break is sort of over, is over now. So if you have the opportunity and I'd encourage it, please read the uh, case study and the Slido poll to follow. The QR code is in the top left-hand corner of the screen, or you can enter slido.com, enter the event code EEHVAC. See you here shortly to go through what we have so far.
And Lester, I think while we're waiting, we did have a question in the chat. I was wondering if now would be a good time to maybe answer that one. Hey Lester, are you able to hear me? Hey Lester, I think you may be talking, maybe muted.
There we go.
Okay,
Can you
great.
hear me now?
Oh, yeah, I can hear your audio now.
Awesome, awesome. I was just saying that if we have anyone still working on the poll, please continue. What we're going to do is we're going to start going through these answers for the case study that we were just reviewing. So what kind of technology was used to design the mechanical plant model? And that was 3D technology. That is the correct answer there. AutoCAD is used a lot of the time, but in this specific case study, the 3D technology is what was utilized for the modeling of this specific plant. Well, anyone in here uses, or do we have any architects in attendance today? That would be nice to know. List some of the equipment you can find in a mechanical plant or room. And we've got a lot here. We've got boilers, we've got air handlers, we've got sprinkler distribution, HVAC, heat exchangers, water heaters, and/or tanks. Very important to note that tanks for several different reasons when talking to your hydronic systems, specifically chillers, your air handlers, your water pumps, your boilers, main distribution piping and valves, very important parts of your distribution system. This is where a lot of your issues are going to be present. You're going to lose a lot of efficiency due to leaks in your piping system, valves, especially any type of valve that has pneumatic actuators operating on them still and currently may have issues, especially if it's using, like I said, that pneumatic system. You still have a couple applications in the field that utilize the pneumatic systems as far as controls are concerned, just because sometimes a lot of these different systems could be like explosion-proof applications. So they have to continue to use pneumatic controls instead of the newer DDC model, which is direct digital controls, where your BAS systems are based off of. So yes, piping is extremely important. Elevator machinery, um, I believe so. I won't. I'm pretty sure it is. Yes. Elevator machinery. In my time, I think I've come across that. Sprinkler distribution pumps and piping, very important stuff. And you will find that, excuse me, within your mechanical room and other HVAC equipment. We have pretty much the same things down here, your HVAC systems, boilers, pumps, chillers, air handlers, water heaters, and tanks, sprinkler systems, chillers, boilers. All great answers. Boilers, very important. I noticed someone put here an MCC, and that is really good catch here. The MCC, the Motor Control Center, you will find located in both your electrical side of the house and also your mechanical side of the house, because your pumping systems, which contain motors, are going to be located on this MCC panel. I've seen panels that, depending upon the size of the facility and also the mechanical room, or the size of the system, might I add, you can have I've seen up to 20 pumps in a mechanical room. So you'd have a MCC control panel with 20 different areas where you have control for each pumping system. So the system could get very complex. Sprinklers and others, MCC flow valve controls, very important stuff there. Gas, water, boiler, circuit panels. You will have a few circuit panels inside of the mechanical plant. Transformers, probably more so in your electrical, MCCS, pumps, air handlers. Mechanical rooms will have air handlers in them. If you have a system, I've seen so many designs of systems in my time working on these different applications, but if you have a system that or a facility that is extremely large, let's say it's maybe 40,000, 50,000 square feet, you'll have a main air handling system which will branch out throughout that entire facility. And you may even have that system have VAVs or VAV boxes embedded into that air handling system. So that way you have even more control over certain or specific zones depending upon your application. So yes, you definitely can find air handlers inside there. Well, at least your primary or main air handling system, ancillary equipment, and domestic hot water operations as well. So all great answers there for equipment that you can find inside or within a mechanical room. I don't know if I saw it, maybe it was there, but water treatment, that's big. You will find water treatment stations. And something else that I didn't see on here was safety station. So if you have maybe gotten a burn or something got in your eye, you can go to these safety stations. It has something where you can open it up, put your eyes down in it, and it'll just immediately flush water in there. There is a chem kit located near that safety station, which all of these items should be there. And if they are not, you need to report it to whoever's in charge of that facility. So that way these things are there. All right, all great answers there. Does mechanical plants house electrical equipment as well? And answer there is yes, 88%, and we've got no, 13%, but the answer there is yes at 88%. And yes, you will have electrical equipment inside of your mechanical plant, because a lot of the time that is what's going to power that mechanical equipment, such as your motors and pumps. You're going to have electrical panels, you're going to have disconnects, you're going to have other items in there, especially for your controls, for any chiller system or any type of air conditioning system. You're going to have control circuit wiring that's sent back to your direct digital control system, whether that's your BAS computer system located on site, or you'll have to have some sort of remote connection able to send that signal out to wherever the remote site is monitoring that facility. So yes, you will have electrical equipment housed inside of your mechanical plant, but it is for providing the power for the operation of those different systems in there. So good choice there. Let's go back really quickly. So, one second. All right, so we just were able to cover a few different items, and then we jumped into the case study, learned a little bit about the designing of the different mechanical rooms that are available out there, different types of design tools and instruments that are used. Now, what we're going to do is we're going to dive in on the different types of testing and data collection tools that are available in the field today that will help us test our different HVAC components. So that way we make sure that these systems are operating as efficiently as they were on day one of installation. Optimum efficiency is what we are aiming for with these HVAC systems. And if we don't have that, what we will begin to see is a decline in the service of these components. And we'll also see a decline in our production within whatever it is that we do, because HVAC is a big part of that application. So each component in an HVAC system requires individualized testing utilizing certain industry measurement and verification tools and equipment. Now, once again, these testing measures ensures the optimum operation of HVAC applications. Any type of faults and other issues plaguing the different types of systems that we've addressed today so far may be intercepted by implementing these different testing measures using some of these instruments. Now, implementing control systems testing plans also creates a log of HVAC equipment operation. So, what you want to do when you are doing these different testing procedures is you want to create some sort of a mechanical, or not even mechanical, but a physical copy of a log detailing all the different things that are occurring with that system. So in my experience, what I've found is that in mechanical rooms around the world, doesn't matter where you go, if you are some sort of a tradesperson, any mechanical room that you step into typically has a log book for certain pieces of equipment, such as a boiler or a chiller. And those logbooks will contain daily check-ins from whoever that technician was for the day that performed that daily routine, or even whatever type of maintenance it is as far as interval is concerned. It is annotated in these logbooks, so that way if there's an issue with this system, you can refer back to the logbook in order to track and see where you may have had an issue. So implementing some sort of controls uh, systems testing plan would help you to do that. So if you had control systems installed on your HVAC operation, a lot of these BAS systems are able to help you with tracking maintenance and tracking any type of services that were performed on these systems by easily scanning a barcode and checking some things off on your iPad. It's gotten to that point, but we still have a lot of different organizations that are not there yet. So we're there, and we're slowly getting there by offering incentives in order to get there. These different utilities are. So a highly recommended practice is to create logbooks in every single one of your mechanical rooms, or if you are running a central plant, whether that be in your mechanical plant or your electrical plant, it is highly recommended to leave some sort of a logbook for historical records review of past operations. Now, the different applications requiring system testing are once again, your boiler system, your chiller system, your pumps, your air handlers, and your electrical systems. These are all the basic systems you'll find within your facility that will require some sort of testing regularly in order to maintain its operation. Okay, so once again, that's your boiler systems, your chiller systems, your pumps, your air handlers, and your electrical systems. So faults and other operation halting issues, like I mentioned, can be discovered and addressed before any bigger problems can arise. So you want to make sure you're following up with manufacturers' recommendations as far as inspections, servicing, per the specific interval, whether that's a monthly, or we could even take it as far back and say whether that's a daily, a weekly, a monthly, a quarterly, a semi-annual or an annual type of inspection or service. Okay, so these have to be done for all these different systems, or you're going to run into a lot of different problems. So what we're going to do is we're going to touch on a little bit on some of these different instrument testing methods and the actual instruments themselves. And on Thursday, we're going to continue that conversation. So we have data acquisition sensors up, which is our next topic of discussion. With these different data acquisition sensors, we're able to have the continuous monitoring of HVAC systems through the use of a BAS system or a building automation system. There are several vendors out there today that provides these measuring systems or these systems that are able to monitor your HVAC use, or even not only monitor, but give you the ability to control. So you have the ability to control and monitor the usage of your HVAC systems. So let's go through the testing and data collection process through the use of sensors when utilizing these HVAC systems. So here's a chart here. We're going to kind of use this as our guide in order to let us see exactly how this process is happening within the BAS world, in a sense. So when we're able to utilize sensors to take different readings for us, we're able to then use those different readings that we're getting from our system and diagnose any type of issues we may be having with that specific system. So you have a 6-step process. 1, determine the quantities to be measured. And then once we move on from there, we'll talk more about these as we go through. I believe this is the same. So yes, so we'll talk about these more as we go through. But 1, you're going to determine the quantities to be measured. So what that's talking about is basically your temperatures, your pressures, your differences, velocity, flow, whether that system is on and off. You can use sensors to determine all of those different values. And you will find these different sensors within your HVAC applications, whether that's in chilled water applications, hot water applications, any type of application that deals with HVAC, you will find these sensors, and they're able to provide you through an output what the different temperatures, pressures, differences in voltages, amperages, velocity, and flow. Even if that system is on and off, you'll be able to determine that through sensors. Then step 2 is determining sensor location and available data. So at this point in the system, you know, it's trying to locate where you're wanting to capture this data, right? So you have the sensor, you know what it does. Let's say you're looking for a temperature sensor. Where in this system are you trying to put it? Are you trying to put it at the supply point where we are measuring the actual air blowing directly across that cooling coil? Or are we trying to measure it at the actual room or zone or site or office where we have the occupant trying to get either cooling or heating to feel more comfortable, right? So these different sensors now, you have to try to figure out where you're trying to read or collect this data so you can make your diagnosis or whatever it is that you are looking for as far as why you're putting that sensor in that location. Now, step 3, collect the raw data. During this phase, you've got data loggers that will be utilized to collect and store that raw data that is picked up by the sensors. So the information collected by the sensors are not readily readable. So these data loggers are going to be utilized to collect and store that data. And one thing about the data loggers is that it runs continuously and it transfers that information to a database or some sort of a PC for analysis in the near future when a technician needs to do any type of diagnosis or evaluation of a system. Now, the data loggers are extremely important in this case because when it comes to running your operation, you want to be as efficient as possible. In order to do what these systems and sensors are able to do, you would need to have personnel on site 24 hours a day. Your data loggers run continuously and transfers that information to a PC database for review or evaluation or diagnosis at a later date. So whether that is you running uh, sensor retrieval report, so that way you could see what's happening with the system's load efficiency, and you want to run that for the evening hours while no one is on site, you have the ability to do that through the use of testing and data collection processes by using sensors and BAS systems. Instead of manning that operation 24 hours where you'd have to send personnel out to those different sites or zones to collect that data, whether that is by use of infrared technology, whether that's shooting a temperature gun at the ductwork or going to physically measure the temperature at the air handler system itself. So you can really reduce your or increase your efficiency of your operation by spending the cost upfront to embed these really sophisticated systems inside of your facility, allowing you to now have these processes done automatically, and then the ability to go back and review anything that is pulled by utilizing these different sensors. So that is step 3, the collect the raw data portion of the process. And then we go to step 4, which we briefly touched on, but that data that's picked up is then processed and analyzed for any type of audits, troubleshooting, or if you have some sort of repetitive issue. So if you have a chiller that is surging every evening or in the middle of the night at 3:30 in the morning, and it does that for a whole week, and you're wondering why operation is sluggish or something is wrong, you're able to go back through the records and look at that because there's no one on site at 3 in the morning watching that chiller in operation, because not every site has the ability to do that. What they rely on is the ability to monitor these different systems through the use of remote technicians that are actually able to watch their systems in operation. I think today, even your utility companies can be of assistance with those processes or refer you to third-party individuals that can provide you with that type of service or technology as well. But this is very good for identifying any type of issues that are plaguing your system. You want to definitely make sure that if you are having issues such as surging with a piece of equipment like a chiller, especially these chillers are expensive. They could go up in pricing, up to around 500K. You want to make sure that this system is not operating the wrong way. And by having these different testing and data collection methods applied to your different systems, whether that's heating, cooling, it will give you the ability to forecast any issues that could potentially affect that system. And then you can have it analyzed and repaired by the company that created it or any technicians that you do have on site. So all of that is part of that step 5 process and analyzing the data that you retrieved from the PC. And then from there, you're going to hit step 6, which is evaluating the output of that data. So what are the problem-solving steps required to solve any of these issues that exist? So what do we have to do next? We found out that we have severe negative pressure in our air handling system. What is the next few steps to handle that? What are we going to do? Do we have an issue with filtration? Do we have an issue with overpressurization? What's the problem? Do we need to upgrade? Are we having leaks? What's going on? Are there any urgent repairs that need to be made? And then finally is maintenance up to date. That's when you're going back and looking at those maintenance logs, if you have them created manually. But if you don't have them created manually, does your BAS system track that? Or you have some sort of soft version of a facility logging system, monitoring system, where you're able to track all of the maintenance that is done to the different systems at your facility. So these 6 steps here will allow you to track, test, measure, evaluate the different systems that you have on site. And if you use this system, it will allow you to operate your facility and also your, all of the different components that you have on site in a much more efficient manner, rather than just running it wildly. I like to, I like when I worked for State Department, I would advise the facility managers to try to do both. I would tell them that their facility staff needs to keep logs on site, manual logs, actual physical logs. So have your day-to-days that run around and do the dailies, have them log everything every day, what the temperature, supply and return temperatures were, what the velocity of air was coming out of the air handler, any delta T's that needs to be measured, uh, water pressure, whatever. Have everything logged every day in a manual logbook. And then if you still have those capabilities at the end of the day or throughout the day, have those technicians provide that data to your data entry personnel that works your BAS system. So that way you have 2 points of data collection, and data collection is always really, really good for audits and also for when the time comes to perform upgrades. Because if you've always taken that data and understand how your system is supposed to operate, when it begins to get to the point where it's becoming inefficient, now you can see trends in that pattern. So from 2000 to 2015, the centrifugal chiller worked phenomenally. But from 2015 to 2020, we've started to see a decline in efficiency. So that's letting us know either there's an issue with the chiller, or we may need to look at potentially upgrading that chiller to a higher efficiency system. And if you have the historical information to provide, especially to utility companies, makes their job easier to help you in evaluating, and not just them, but your technicians or the contractor that'll be called in order to remedy the issues. It gives them a point to start. So data collection is an extremely, extremely, extremely important process when dealing with these HVAC systems. And once again, if you are able to perform data collection, what it will do is it will help you to create and have a very efficient process at your facility and or site, especially within your facilities team. If you make that something that is a requirement every single day, you will have a smooth and very clean running operation. So give me 1 second here. All right. So we have come to the end of our broadcast for today. We still have a few minutes, and I think what we're going to do with those few minutes that we have left is kind of hang around just to see if we have any questions or anything that we can answer for you. But let's go into a quick review of what we went through today. And pretty much we went through an introduction to HVAC system testing and how do we do that for having the most optimum energy efficient facility possible. But what we were able to do today was first discuss, what services are provided to facilities which come directly from mechanical and electrical plants. And we touched on a lot of different points there. We touched on what services comes from electrical, what comes from mechanical, as far as electrical being the power production and mechanical being all our domestic hot water services, air conditioning, heating options. And, from there, we dove even a little bit deeper and touched on some of these electrical systems in depth, such as the switchgear and motor control centers, and even some of the different types of transformers we might see available out there in the field. Touched on a little bit of solar options as well. And on the mechanical side, we dove a little deep into the chiller applications and described what those were and how they operate, and boiler systems, and even uh, mentioned our pumping systems and touched on how those are important in the system as well. But one of the more important sides to remember about these systems is the most important part, which is the final destination, the air handler unit. It's not quite the final destination, but it is as far as where that chilled water or that hot water from the boiler system or chilled water system will be going to before it goes through its heat exchange process at the cooling coil or at the heating coil of that air handling unit system. So we're able to drill a little deeper into those different electrical and mechanical systems. And once we got done with that, we were even able to start diving into the actual process of that data collection and how we're doing that and why and how that allows us to make our operation at our facility or site much more energy efficient. And on Thursday, we're going to dive a bit deeper into those different instruments and tools that will allow us to test and make sure that we have the most energy efficient operation possible when working with these different facilities. So that ends our broadcast for today. But what we're going to do is we have roughly about 6 minutes left, and we're going to hang around and see if we've got any questions, or anyone has anything that they're wanting to bring up. We can definitely talk about that. But I do want to thank you all for hanging out and being on call with us today. And I look forward to seeing you all back here on Thursday to go through day 2 and dive into the nitty gritty. I think this is the fun part. This is where we get to see some of these really cool instruments that are used to really identify any issues that we're having with these systems. So once again, thank you for your presence today, and I look forward to seeing all of you back here on Thursday.
Yeah, that was great, Lester. Great overview of the HVAC systems, and I'm really looking forward to Thursday's class. So just as a reminder to everybody, most everybody's still here, go sign up for the day 2 if you haven't, otherwise you won't have a weigh-in at lightingdesignlab.com. And we'll see you back here on Thursday.
So I'm going to still hang out here for a little bit. For anyone that still has any questions, feel free to put it in the chat. Danny will let me know if there is anything out there.
Yeah, absolutely, Lester. It looks like we do have a couple questions here. And I guess we can address those now, but the first one goes back to the chillers. And we have an attendee wondering if the absorption chillers are mainstream.
No, absorption chillers are typically used in very specific applications. In my career, I haven't had much interaction with absorption chillers. You'll find these absorption chillers mostly in the industrial manufacturing sectors. I was more so in the commercial government sector where we dealt more with information technology and facility cooling, facility process cooling. But yeah, you won't find these absorption chillers too many places. And I believe that's because of the type of refrigerant that it uses or utilizes, which is pneumonia. I think they're looking to try to go away from the use of absorption chillers. If I'm not mistaken, I could have swore I read an article about that somewhere. I will look for it. That's the second thing that I need to write in here. The first one is the heat recovery option instead of utilizing actual natural gas, or you do have heat pump options now where heat pumps today are much better than they were 20 years ago. So when I first started installing heat pumps, you couldn't utilize a heat pump here on the East Coast below 32 degrees Fahrenheit. You would freeze. You would need some sort of auxiliary heat in order to back that heat up, or it just wouldn't work. I had a problem with that in Texas. I installed 40 packaged units for the Air Force, and that winter was an extremely cold one, and they called me and said that the heat wasn't working. So we had to go back out there and reinstall, uh, uh, purchase and install auxiliary heat packages, which were electric resisted heating, and install it in the system and rewire everything up and get it up and going. But it worked. But they hadn't had the opportunity to use that ever again because um, Texas doesn't get that cold. That was just one winter that really went south. So uh, yeah, there today, 20 years later, you have heat pump technology, heat pump systems that utilizes carbon dioxide as refrigerant, which can reach negative 20 degree uh, uh, operating status. So it can work down to negative 20 degrees, producing domestic hot water, or I believe now you do have heat pumps that can even provide you with heating, not domestic hot water, but actual comfort heating that can operate at sub temperature levels. So the yeah, it's out there. It's definitely out there, but it's not. It's not. These are things that are not in constant rotation. I think starting the first of the year, though, with a lot of these different governmental uh, interactions with these different systems, you're going to see a change in how things are moving as far as people actually having or getting the ability to install or have these systems on site, whether that's residential or within the commercial population or community. You're going to start to see that, I believe, from the first of the year. Starting with HVAC systems, there's a new system that is being pushed very hard throughout the residential community that deals in a different SEER model. So I have some information. I'm doing some research on that for the company, but I'll Thursday, I'll talk a little bit more about it, so that way you all could have an idea of what's happening out there as far as regulation is concerned now. But it's changing drastically and it's moving fast, so we want to stay ahead of it as time goes by. I think I went on a little bit too much on that last one, Danny. Did we have any other questions there? I ramble a
We did
little
have
sometimes.
Oh, it is all good. It looks like we do have one more question which we can hit. We do have a bit over, but there's a question in the chat asking, would you recommend any sensors for retrofitting old school equipment?
No, no. I would recommend OEM parts for that old school equipment. It works with it, and especially if it's an older model, it's an older model piece of equipment for a specific manufacturer. Prior to a certain date, they don't like to work with other protocols. So if you have like a carrier sensor in a train unit, from 95, it won't work. It might not work. I know in the past for me, it hasn't. So, and that was because there was a lot of IP, intellectual property stuff going on with these companies prior to, I think, 2000. It was just a lot of back and forth. But now these protocols all talk to each other, and there are ways to make them work. So what I would recommend on older models, systems, go OEM, contact the manufacturer vendor directly, and if the part or sensor is no longer being produced, there are other places you can go to find it. But really evaluate your system at that point and see if it's efficient to have it still first. But if it's costing you money to maintain it.
Awesome. Well, it looks like that's all the questions in the chat. So,
All right.
yeah, that should conclude our time here, it looks like.
Okay. Sounds good. If we don't have anything further, once again, I just want to thank everyone that made it to the presentation today. Look forward to seeing you all back here on Thursday for part 2 of HVAC systems testing for energy efficiency. I think we should be able to close out now, Denny.
All right, let's do it. Bye, guys.
Bye.
Bye.